A uniform wire of resistance 100 ohm is melted and recast in a wire of double that of the original length. What would be the resistance of the wire? Because resistance changes when length and area change, but resistivity remains same because material is same. So we have to first calculate the length of the new wire. So now the volume will remain same because volume does not change, the volume of material does not change. So we can write V1 equals to V2. Now pi into R1 square L1 equals to pi into R2 square L2, or this implies L2 by L1 equals to R1 by R2 square, or this is given that L2 is twice, so 2 L1 by L1 equals to R1 by R2 square. So hence R1 by R2 equals to root 2, and this imply R2 equal to R1 by root 2. That is, we have calculated the cross section, radius of cross section, which is equal to R1 by root 2. Now we know that now we can write R2 equal to rho into L2 by A2. So we can write rho into L2 by pi into R2 square. Now putting the value, rho into length becomes double, so 2L1 divided by pi into R1 square by because R2 equal to R1 by root 2, so we have placed this value. So R1 square by 2 equals to 4 into rho L1 by pi R1 square. Now this is the original resistance. So 4 into rho L1 by A1 because pi R1 square area of cross section, so A1. Now this is R1. So 4 R1, 4 into 100 ohm equal to 400 ohm answer. Next question. What length of a copper wire of cross sectional area 0.01 millimeter square will be needed to prepare a resistance of 1 kilo ohm, and resistivity of copper is given 1.7 into 10 to the power minus 8 ohm meter. Now we have formula R equal to rho into L by A, hence L will be RA by rho, and resistance given we have to make 1 kilo ohm resistance, so 1 into 10 to the power 3, and cross sectional area is given in millimeter square, so we have to change it in meter square. The 0.01 into 10 to the power minus 3 to the square, and divided by rho, the value of rho is this 1.7 to the power minus 8. So 10 to the power 3, 0.01 into 10 to the power minus 6, 1.7 into 10 to the power minus 8. Now solving 1 by 17 to 10 to the power 4, which is equal to the 0.0588 into 10 to the power 4 meter, or 5.8 into 10 to the power 2 meter, or 0.58 into 10 to the power 3 meter, equivalent to 0.6 kilometer answer. 0.6 kilometer. Sorry, kilometer. Yes, the 0.6 kilometer, that means there's 600 meter wire can be formed. Now calculation of resistance. When the resistivity of a material remains constant, in this case R proportional to rho into L by A, in eliminatory form we can write dr equal to rho into dx by A, or hence R equal to integration dr integration rho dx by A. For example, here in this case R equal to rho into L by A, so rho into L by pi R square, this will be the resistance. Now in this case a hollow cylinder is given, whose inner radius is A and outer radius is B. Then we can write rho into L by A, or rho into L by outer area square minus this will be the area of cross section, because we have to remove this area because it is hollow. So pi b square minus pi a square equals to rho into L by pi into b square minus a square. Next, in this case we have to find the like this. So R equal to rho, current is flowing along this direction. So rho into L by A. Now rho into L will be, we have to take average distance of this length. So will be average distance will be pi r2 plus pi r1 by 2, and thickness is given, cross sectional area will be, if this thickness is t and this is t, then area of cross section will be t into t. So t into d, and so finally we get rho into pi into r2 plus r1 divided by 2 into t into d. Here it is given r average we have calculated r2 plus r1 by 2. Next, assume that b minus a is very less than L. Find the resistance of the conductor. This is shown. We have to find the resistance along this direction. Resistivity is given and length of this shape is given L. Here the situation is shown. This radius is A and this radius is B. So we draw a line from the parallel to this axis. So this will be A, this distance, that is this distance will be A, and this distance, that is this distance will be B minus A, and so we consider a disk of thickness dx at distance x from this end, a smaller end. So now if this length is y, that is this length is y, that is area of this radius of this area, radius of this disk is y, then this distance from this distance here, this distance will be y minus a, because this whole is y, and from this it is a, so this will be y minus a. Now if we consider this angle as theta, then we can write tan theta in this smaller triangle. Tan theta equal to perpendicular by base, so perpendicular will be y minus a by x, and it is also equal to, if we consider this whole greater triangle, then it will be, this length is b minus a and this length is equal to L, that is length of conductor, so b minus a by L. Now we have a relation between these two, y minus a into L equals to x into b minus a, or this implies Ly minus AL equals to xb minus xa, or hence differentiating hence L into dy, because L is constant and y is variable. If we change a disk, replace disk from, if we take here, then y will change, if we take here, then y will change. So y is variable and it is varying. So L into dy by dx, this also is constant, 0 equals to b minus a, because dx by dx1 and dx by dx1 to b minus a. So this implies L dy equals to b minus a into dx, hence dx equal to L dy by b minus a. So resistance of element dr, we have to calculate first resistance of this element. Dr will be rho into dx, because length is dx, so rho into dx by, an area of cross section is pi y square, so rho by pi I square into, now dx, value of dx is L dy by b minus a, hence total resistance of this whole conductor will be integration of dr, integration of rho l dy by pi into b minus a y square. Now we have to see the variable here. These all are constants and we have to take the limit. So here variable is y, so limit will be according to y. How our y is changed when we take at this point, y will be at length of a equal to a, and if we take disk at this point, then y will be the length of equal to b. So our limit will be from a to b. Now a to b rho l by pi b minus a dy by a square. Now this is in this is constant, so it come out of the integration. Now integration of dy by y square is minus 1 by y, or a by b, or equal to rho l by pi b minus a into 1 by a minus 1 by b. Now rho l into pi into b minus a into b minus a by ab equals to rho l into pi ab. Answer. Next, the region between two concentric spheres of radii r1 and r2 is filled with a conducting material of conductivity sigma. Find resistance between the spheres. This is a sphere and it is covered by another sphere, and the material is of sigma. Conductivity is given sigma. So it can also be solved with the help of elementary form, taking elementary form. For example, consider an element of thickness dr. We are taking element of thickness dr at a distance r from center, and it resistance will be given. Here it is first it is clear that current is flowing from center to circumference of the spherical body, that is current flowing from in radial direction. Okay, so we have to take the cross sectional area as a area of a sphere. So rho into dr, length will be this in this direction. So rho into dr, because this is of thickness dr, so rho dr into, and its area will be, cross sectional area will be 4 pi r square, or equals to 1 by sigma, because rho is equal to 1 by sigma, dr by 4 pi r square. Hence r equals to integration of dr, integration of r1 to r2, because we have to calculate from this to this value. Resistance of this part we have to calculate. So r1 to r2 1 by sigma dr by 4 pi r square, or 1 by sigma 4 pi we have taken common. Integration of r1 to r dr by r square. Now 1 by sigma 4 pi integration of dr by r square is minus 1 by r, r1 to r2, so it will be 1 by sigma 4 pi 1 by r1 minus 1 by r2, or equals to r2 minus r1 by sigma 4 pi into r1 r2, or rho into rho sigma is equal to 1 by sigma is equal to rho, so rho into r2 minus r1 by 4 pi into r1 into r2. So this is the answer, final value of resistance. Next question. Find the resistance of a annular disc between center and periphery of the disc. The thickness of disc is T. Here it current is flowing this time, and this is a disc, not a sphere. This is a circular disc, annular disc. This part is hollow, and in this part material is filled of conductivity sigma. Then we have to find and current is flowing like this from this direction to this direction, and the thickness of disc is given, it is T. Now dr will be, if we consider a elementary ring at a distance dr, then dr will be, that is elementary resistance of this uh, ring will be rho into dr, because length will be in this direction, so dr into 2 pi r, because length into width will be given area, so 2 pi r into 2, thickness given, the thickness of disk is given. Hence r equal to integration dr integration into rho dr by 2 pi r t. Now rho by 2 pi t common, and integration from this area is a, and from e to b, so a to b dr by r, rho into 2 pi t, and in integration dr by r is log r, a to b, or rho 2 pi by t log b by a, or 1 by 2 pi t sigma into log b by a will be the answer. Next, here it is given, we have to find the resistance along this direction, because current is flowing in this direction, and this is of radius a and this radius is b, and material is filled between these point from here to here, and whose conductivity is given sigma, and this length is l, that is, this is a hollow cylinder. Now again we take a elementary ring at a distance r of thickness dr, then dr will be, so we can write dr equal to rho dr by 2 pi r into l will be the area of cross section for current to flow in this direction, so 2 pi r into l, so integration, hence r will be integration dr integration rho dr by 2 pi r into l, and integration rho by 2 pi l integration from a to b dr by r, rho into 2 pi l integration log r a to b, so rho 2 pi l log ln b by a. So this will be the resistance of this given material in if current is flowing in this direction. Case B, when resistivity is variable, that is function of x or anything. For example, here when resistivity is a function of x, that is distance from center to outward direction, in this case we have to write dr equal to rho dx by 2 pi r into l. Now given rho is alpha by x square, so we have to put value of rho as a alpha by x square, and then integrate from a to b. So rho dx by 2 pi r l into x, now putting the value of rho 2 pi l alpha by x into x square dx by x square, so alpha dx by 2 pi l into x cube. Now this all value is constant, hence r integration dr integration a to b alpha dx by 2 pi l into x cube alpha by 2 pi l a to b dx by x cube equals to alpha by 2 pi l integration minus x to the power minus 3 plus 1 by x to the power divided by minus 3 plus 1, or taking minus alpha by minus 4 pi l 1 by x square b a, so minus alpha by 4 pi l 1 by b square minus 1 by a square, or alpha by 4 pi l 1 by a square minus b square. This is the resistance for that condition. Now next problem is, here it is shown. Now in the case of that was the case of cylinder, and it is the case of hollow sphere, and radius given, hollow part radius is a, and filled and the whole radius of sphere is b, means this distance is b and this distance is b. So and from here to here in this part material is filled whose resistivity is given rho equal to rho naught plus alpha x, that it depends on distance x, here it is shown. So we can write dr equal to rho dx by 4 pi x square, rho into L by A, and rho, because rho has value given rho naught plus alpha x into dx by 4 pi x square. So hence integration from A to B dr, A to B, putting the value of rho naught plus alpha x divided by 4 pi x square into dx, or A to B rho naught by 4 pi x square dx plus A to B alpha x by 4 pi x square dx. Now these are constant, so rho naught by 4 pi A to B dx by x square, again this is constant, alpha by 4 pi and x cancel, so 1x will be left, A to B dx by x. So we get rho naught by pi A to B dx by x square alpha by 4 pi A to B dx by x. Again this is rho naught by 4 pi dx by x square equal to minus 1 by x, and its integration in log x. So it will be rho naught by 4 pi 1 by a minus 1 by b, and this will be alpha by 4 pi log b by a. Here log means ln is written for the log to the base e. When our log is on the base e, then it is written as ln. But you can read, you have to understand yourself that if it is written as ln, it is also log, but it is on the base e.